Thank you, Samir, Kapil, for this wonderful platform that we are here today. Good day to all of you who are participating and all our viewers out there. And welcome to this roundtable on building new age architecture and stack using the power of quantum computing and hyperscalers. This is an event as part of the Spectra by 3AI. And thank you all, and thank you, the 3AI, for providing this platform and the reach that we have today. So today we'll be sharing the thoughts on the impact of quantum computing and how it will bring about the next generation of the computing stack and an architecture that we can build upon it. Scaling is very important, and we'll talk about hyperscalers and how computing is going to impact the current or the future generation of hyperscalers. Welcome all of you to this wonderful platform. Let's start off with Saurav. Saurav, we understand that computing, quantum computing as we know it, is still an enigma today for most of us out there. So could you give us a brief on what it is and how does it differ from the current generation of computers which are there?
Yep. Thanks, Jojo. So before I'll start with the quantum computing, right? I just wanted to tell you guys a story behind it because somehow when we talk about this quantum computing, right, it's intricately linked to India, right? So it can be tracked back to the legacy of Mr. Satyendra Nath Bose, right? Who was the actually who is the Indian theoretical physicist, right? Renowned for his work on quantum mechanics and the pioneer of quantum statistics and the condensed matter physics, right? So and I was just reading somewhere like he wrote the last of the four publications that led to the foundation of quantum mechanics. So and that was that paper got published in 1924. Think about 1924, we are in 2024, so almost 100 years now exactly. And then yes, and then he, because now in SN Bose National Center for Basic Sciences in Kolkata, so that actually they are actually going ahead and celebrating those 100 years of publication of Bose paper, right? So when it comes to the quantum computing, right? So quantum computing basically, it leverages the principle from the quantum mechanics to resolve intricate problems, that can, at the accelerated rates. So when I say at the accelerated rates, definitely it has something to compare with the classical computers also, right? So, but we'll not go into detail of the classical computers. We'll look at that, but definitely, when someone talks about the quantum computing, it actually talks about both. We'll have to take care of the hardware research, we'll have to take care of the application development, which is going to play a crucial role in the quantum computing. uh, Quantum computing also uses the specialized technology, including the computer, as I mentioned, like the computer hardware, and definitely there are algorithms that take the advantage of the quantum mechanics to solve the complex problem that classical computers or the supercomputers can't solve. Is it the right statement? Maybe yes. And there is one more item which is or can't solve quickly though, right? So maybe those things are not able to solve it very quickly, and then that's how the quantum computer basically
Okay.
going for us, right? So
So basically, it is the next generation of compute with
right,
large power and large capabilities all mixed into one. And
correct.
it's okay, great. That's a good introduction to quantum computing. So Ravi, tell us the when it comes to scaling, you require large capacity for scaling, right? Large number of servers, large number of compute power and hardware. So when you take quantum computing, is it possible to create that kind of a scale and use it for hyperscaling purpose, or is it limited to the infrastructure what is very specific and specialized for that?
Yes, see, basically obviously the one of the hyperscaling is the word, the where we are actually talking about adding more nodes to your, to handle more kind of, loads, basically, right? Now, in the current stage of quantum computing, it's basically in early stages. And although it has got a great promise, where you can say that, several types of problems compared to your classical computers, it can handle a lot of complex issues and all everything, right? But there are a lot of environmental condition. There is a lot of cost to it in terms of we talk about quantum bits, right? So basically to build that kind of quantum bits, it obviously there is a lot of cost to it. So specifically when I was looking at some research materials, one quantum bit, it's actually takes around almost $10,000 somewhere, right? So it's very expensive. Now, as we move on, probably the technology and the environmental conditions and the more and more people get into building such kind of solutions, probably the cost may come down. But the major thing in this in building this kind of architecture, it's the environment condition where you want to get the quantum bits into the stable condition, right? I feel there is an opportunity, obviously, in next 5 to 10 years. There is opportunity to have many the quantum providers, basically quantum computing providers. And also the we all have to look at when it will be available as a quantum computing as a service on the cloud. So I think that's the state actually which we have to look into.
Okay. Uh, Kapil, what are
Yeah,
your views on this?
right. I think both Jojo and Ravi, think did a great job at covering some of the the advantages and talking about the limitations of this technology. And I could agree more. I think specifically the point that Ravi made, right? It's a fragile technology right now, still in infancy, and you really it relies on maintaining very low temperatures and having these cryogenic settings. So my view is, right, this will really hyperscale once probably you have this qubit at a room temperature, right? If I were to draw parallels or comparisons, I mean the nearest technology which comes to my mind is having GPUs.
Okay.
And GPUs are, as we all know, right, especially the ones who have been in this machine learning field, they've like really revolutionized the way we think about computing now. So with this large AGI models with like a lot of billions of parameters, I can only imagine what quantum computing will do once it's becomes mainstream. And I think the last point that I want to add is I just feel that this is going to be more like a turbo, right? Like just the way we have like a turbo in our engines, right? I feel it the right model, like Ravi said, it once it sort of gets becomes a quantum computing as a service, will be like a hybrid model. So the way you have CPUs and GPUs right now, I feel it will be like going forward. It'll be like a GPU and a quantum computing, right, which will sort of help you, boost or do give that turbocharge to your computing needs. And I think that's the future, and we're really excited about it.
Okay, that's great. Connected with this Manimaran, can you throw some light into how we are I mean, is there something happening parallel to meet the energy requirements for this kind of hyper computing or scaling up the quantum computing? Because you know that even Chat GPT running a few AI models take up enough energy to run a few cities in the world. So how are
Correct.
we going to meet these energy requirements?
Yes, Jojo. So, as we all know, quantum computing offers unimaginable processing power and speed, which helps in optimizing our AI models. So, we don't want our AI models to run for hours together or days together to give the predictions. We want the predictions to be done at the earliest, so that it helps the our stakeholders. Because if there is a delay in getting the prediction, it may affect the business. We may lose a business opportunity. So it is directly linked to the business and the revenue and all that. So if you look at the classical computing, if you look at the total cost, the cost of energy is dominant. It's the same is the case with quantum computing, because it is very optimal at the cryogenic temperature. So energy spent to handle these computationally challenging tasks is also very high. So while we are dependent on quantum computing, there are various significant amount of money invested in research to scale up quantum computing and to handle the energy consumption. So there are a few some of the important techniques which are under research, or using silicon-based quantum computing using CMOS technology. There is another method called exploiting parallel and adaptive architecture to scale up quantum computing, and also hybrid approach, which was already mentioned by one of our panelists. Hybrid approach is also considered to be used, and also annealing based quantum computing is also considered to sort out this problem.
Okay.
So, yeah.
All right. So, which means that we require a lot of energy and a parallel, research or parallel engagement has to be made to provide this kind of energy. And probably renewals are going to play a lot of importance, or something like hydrogen power might come up to power all these things. So, Saurabh, where do you think that we are talking about GPUs and comparing it with today we have CPUs and GPUs and even GPUs and neural processing engines, which are even in the laptops and computers. So, even if not to that scale, when do you think the quantum computing is going to escape the labs and current setup and be made available to the masses? Do you have a time frame?
So if you look at the because see, if you look at from the India's current the kind of like the where exactly we are is staying in. So if I read out the couple of articles, and then early 2024 there was a couple of the announcement which has made it on. So in 2023 itself, right, India has become the seventh country to have the national quantum mission, which is after US, Austria, Finland, France, Canada, and China, right? So we are now at the seventh side of it, right? So definitely, so and there is a and with this particular mission, right, which is completely geospatial, right? There is a lot of R&Ds which is going on. There are a lot of the Indian Institute of Sciences as well as the IITs which are getting involved in this quantum research. There is a over of under the mission, right, under this completely the India mission altogether. There are close to 6,000 crore which has been funneled, right, uh, starting from 2023, 2024, and they'll have to spend this entire amount until 2020, 30, 31, right? So
Okay.
that's the seed, right, which has been given to this. So I can see definitely, there is a significant growth and development which India is focusing in on right now, and definitely in this current field, uh, we are somewhere close now.
So, Kapil, India is taking its step forward. What do you think is happening in the world outside? I mean, how early can you expect this to reach common man, a
Right.
student, for example?
So, Jojo's, I feel it's anybody's guess because some of this research is really done in stealth mode. I mean, if we know reverse and rewind 2 years back, who knew that ChatGPT will sort of take the world by storm, right?
Yes.
And I think the state of quantum computing is same right now. So although people do talk about it, like Google CEO talks about it, Sundar Pichai basically talks about it, and all these people are sort of investing in these technology. It's just that the common people like you and me are not aware of it. So one fine day, who knows, all of a sudden somebody might come and say, oh, we have like a quantum computer behind Gemini, which
Okay.
will be doing things 1,000 times faster, right? So to be honest, I feel it's anybody's guess, but I'm really sort of banking upon like maybe next 5 years, we might see a new revolution, especially given the size of these large language models, the way they're growing. I feel the necessity, it will become more of a necessity, right, to power that compute.
That is true. I mean, from a very few tens of thousands of parameters which were initially used in the initial models, we have reached up to no billions. I mean, hundreds of billions of parameters which require time and energy to train and deploy. So, connected with this, Ravi, my next point is this: we say about artificial general intelligence. So, with the normal compute, normal in the sense non-quantum computing, even with the power we have today or which we are planning to develop, the time it takes to reach such as general intelligence for our current models or new models is probably a little long. But with quantum computing coming in, do you think it will, happen before? Is there a chance that AGI will come into the forefront, and all the associated fears with AGI? People talk about terminators and all of it. So, how do you see this relating to quantum computing and the development of AGI?
See, that's a very insightful question, in my opinion. I'll tell you because the AI, in the world of AI, the fear of AGI, where like machine is possessing to do all human-like work, right? That itself is a big debate and speculation. That's first thing. But obviously, when you are getting into the world of AGI, the number of computations what you require to do, right? It's huge, very complex, right? Obviously, the quantum computing with the supercomputing power, obviously it makes it possible, right? Because it is based on like as we've been discussing, it's based on quantum mechanics, and it can process the vast amount of data, right? In the matter of seconds to minutes to seconds, and it can reduce number of like days to weeks to days and something like that, right? So obviously there is a lot of hope and promising stuff coming for AI, in terms of in achieving the AGI. The quantum computing will play a significant role. That is no doubt about it. Having said that, obviously, as we have been discussing, the lot of technical challenges, and then how to use it and applications of it, and and again, is it available only for the big giants, or is it going to be available for the common? When you look at now in the AI models, also we are talking about a lot of open source models, those kind of stuff. Apart from the big giants who are actually releasing the models, the large language models, right? And I think, in my opinion, keeping a bit of on the responsible AI, and then keeping a kind of that. The AGI can bring into us, and then quantum computing certainly can play a big role, in my opinion.
Kapil, what are your thoughts on this, on the AGI part of quantum computing?
See, I think data is definitely one dimension to it, but when I look at the way AGI people are thinking about AGI, it's about building more planning, building more reasoning, giving the model or AGI a more physical reality of the world, right? So they can do some common sense task, right? So in my view, I think the way I'm thinking about AGI is like having some sort of like a multi-agent framework
Okay.
where all these agents sort of coordinate with each other to execute a task or answer a question. Currently, if you look at LLMs or large language model, it's more of an input output. But I feel going forward, it'll be like having like a giant agent which is sort of controlling so like all these mini agents, and all these mini agents will be powered through some sorts computing power is needed, right, for
Okay.
them to interact, for them to compute. So my viewpoint is that data is definitely important, but equally important is are these small agents who sort of coordinate with each other and execute a task. It's similar to the way we have the neural network in
Yes.
our brains. Each neuron is sort of coordinating with each other. So I'm just sort of taking and building onto that concept and taking it to multi-agent framework.
Yeah, I think it's very interesting, that kind of a thought process, because we are looking at independent standalone models right now, even LLMs or stable diffusion models which are there. So you are thinking of a giant coordinated multi-distributed compute model framework. I think that will play an important role in deciding what kind of architecture the future compute systems are going to be built on, right? So, we are coming towards the end of our time for this discussion, but was one very important thing I believe we need to touch upon. That is the geopolitical, considerations for this kind of development. Saurav earlier spoke about how India is going to, how India's will be placed. So there's a lot of competition happening, and today the world is seeing some kind of a lithium or raw material kind of a competition. It was oil, industrial revolution, so every age had its own. So when it comes to quantum computing, do you see that kind of impact sort of in the geopolitical scenario?
See, when you talk about the geo side, right, of it, right, I'll still feel that then to have the significant growth and the development side, there are few portions, not even few portions, but there are certain 4 or 5 points where we should have to be focused on. The first one is definitely about the investment, right, which we have already talked about, that okay, there is a 6,000 crore which needs to be taken care from 2023 2024 until 2030 and 31. But apart from it, there has to be a collaboration, right, which is still needed because, as everyone is talking about, right, that it's pretty much new. And if you are talking about that big giant, the LLMs and everything to run that, you need to foster some sort of international collaborations with the leading quantum research institutions and the tech companies, right, where they can actually go ahead and share some knowledge and the resources. That's another thing. The third thing which I can definitely talk about is the education and the training, right? That's the one of the most crucial nowadays. If you'll go back to ask about anyone with the quantum, they'll just say qubit, right? And then the normal byte, right? That's so you'll have to understand the qubit and how it is exponentially growing and everything. So that kind of also the education and training which is required, and definitely the industry partnership, right? So we have seen that there are some sort of encouraging the partnerships between the academia and the industry to accelerate this commercialization of the quantum technologies. And last but not the least, definitely about the policy support, right? Because you'll have to at the same time you'll also have to go ahead and you'll have to protect your intellectual property in this quantum research. We have seen there is a lot of things which has happened with respect to the AI, but yeah, there is one more this policy support which is required. So I think we are going in the right direction. It's just like we'll just have to focus on a few of these items to go ahead and make it success.
Okay. Debbie, coming to you on this regard, do you see a struggle happening between companies or countries to gather some kind of a momentum or you know what will broader acceptance or even come out in the forefront of this kind of competition? Do you see that happening soon, or is it still limited to a few players in this at this time?
No, obviously there is a struggle. There is a people want to their own put their own remarkable their fingerprints on these kind of upcoming technologies. Obviously, who owns the tech and who owns certain parts of stuff, and obviously they rule the world, kind of thing, right? We have all seen the 5G, those kind of stuff.
Yes.
Now, obviously, every country they are making some kind of investment and then doing these kind of developments in a small pockets, right? Now, India has come up with a quantum mission, and then they have invested some money. They have also put a roadmap. They want to bid. They want to release qubit for 50 to 100 qubits in next 5 years, and then so on and so forth. Right? Every country is making that such kind of progress, and where in US market, if you see the Google kind of companies, they've already started investing in this kind of stuff, like the as a private tech companies also, right? So obviously there is a struggle, but I strongly feel I think it's a great time to bring in some quantum consortium kind of thing where they bring in these kind of companies, the tech companies or the countries who are investing in it, so that they invest in more cautiously, and the things will happen more in a more collaborative way. That's what I feel is more much
Yes.
required at this moment, and also which we can control where we can apply these kind of technologies, these kind of the quantum mechanics, so that we are more controlled and we have some regulatory bodies, so that it doesn't get into the hands of some few billionaires, and then they do some certain things, and they become a superhuman in certain way, and then you have a common man in the other side where they're not able to afford for this kind of stuff,
Correct.
right? I think I feel that there is a requirement for that.
Yes, and in fact, ethics play a very important part as and when we have this kind of a compute power, and it's always essential that it is all spread across more than many players, I would say, so that there's a distribution of power. So we are coming to the time is always a sin of premium, and we are almost at the end of it for this particular roundtable session. So it was very interesting to look at hear from you all and. Different perspective, which is into a very very nascent and upcoming field, and computing as such, or even the artificial intelligence and the related areas are seeing a lot of growth and potential these days, as well as threat. So we cannot ignore that as much as well. So thank you all for being here as a part of today's roundtable. And thank you, 3AI, for giving us this platform once again. It has been wonderful knowing you all and interacting with you over the past few days and weeks to settle this up and have this very, very meaningful and fruitful interaction. So I'll hand over back to Samir and his team. Uh, Thank you so much and have a beautiful day and beautiful time investing into AI. Thank you.
Thank you.